Hello, cloud gurus. If you're using Kubernetes, it's important that you understand services. And that's because services are the abstraction that define a logical set of pods and a policy to access those pods. And sometimes these are even called microservices. The reason that we need services is because that most Kubernetes pods are stateless. And that means you start up a pod and when it dies, it never comes back to life. And the IP address associated with that pod doesn't come back to life either. So you can never rely on specific applications being on specific IP addresses. So how can one group of pods, for example, a group of front-end web servers, access another group of pods, for example, a group of back-end database servers? You can't trust the IP addressing, and honestly, DNS is just not that reliable in this use case. So while pods have their own unique IP addresses, those IP addresses aren't exposed outside of the cluster without a service. So while one pod can communicate with another pod on the same node, there's no inbound communication from the LAN or the network without exposing those pods. And there are really 4 different types of services and 3 that are most popular, starting off with cluster IP, and that's the default. If you create a service with a cluster IP service type, that service is only accessible intra-cluster or within the cluster. If you want a service to be available on the IP of the node that it's running on, you would use the node port service type. Then there's the load balancer service type, which exposes the service externally using a cloud provider's load balancer. Or if your Kubernetes cluster is not running in the cloud, you can define your own on-premises load balancer. And then finally, there's the external name load balancer, which creates a DNS CNAME record, for example, web.server.com. Now, you can either create services imperatively with the expose command, which I'll show you how to do in a moment, or declaratively using a YAML or JSON file. Now, it's probably beyond the scope of this fundamentals course, but most production clusters expose web-based applications, meaning HTTP or HTTPS, using what they call Kubernetes ingress controllers, which isn't really a service type, but it allows external access to the group of pods that are running the web-based application. Now, the simple command to see the status of your services is simply to run kubectl get service or SVC. If you want to expose a deployment to the network, you can use the kubectl expose command. You specify that you want to expose a deployment, the name of the deployment, the internal port on that deployment, the port number that you want to expose it on, and then in this case, we're using the service type load balancer. Now, you can also, of course, create a service with a YAML file using the declarative model, simply by using kubectl apply -f, and then pointing that to the name of the YAML file that you created that defines the service. Now let's go over into the lab and I'll show you how to expose a deployment, and I encourage you to follow along. We're here in the lab, and if we do a kubectl get deployments, you can see we have the Web1 deployment that's been running since we created our very first Kubernetes application. If we do kubectl get service, you can see we do have 3 different services already created. The Kubernetes cluster IP, which is there by default, and then the WordPress load balance service, and the WordPress MySQL service, which is cluster IP. Both the WordPress and WordPress MySQL services were set up in previous lessons. What we're going to do now to expose our Web1 Nginx web server, of which there are 2, you can see up here, there are actually 2 pods that make up that deployment, and both of them are ready. So what we need here is a load balanced service that will distribute the load randomly between those 2 pods running our Nginx web server. What we're going to do is to use the kubectl expose command, and we're going to expose that deployment called web1. We'll do --port equals 80, because that's the port that those web servers are going to be expecting a connection on, and then the type is going to equal load balancer. And that is case sensitive, by the way. And there you go. We just created the Web1 service. Let's do kubectl get service. And there you can see the Web1 service was created. Now, normally you could access it on this IP right here that was created. However, since we're running Minikube and that cluster is actually in a virtual machine, we need to use Minikube service and then the name of the service, which will open up our web browser, pointing it to that IP right there, which is actually the IP address of the Minikube virtual machine, and then the port that Kubernetes assigned for the load balancer on top of that IP. And here's exactly what that looks like. You can see we're pointed to that IP address, the IP address of the Minikube virtual machine with the port number that was created for the load balancer. And that's going to point to the IP address where it says server. That's actually going to be the IP address of one of the pods that makes up this Kubernetes deployment. In this case, it's Nginx. And now notice randomly, every so often here, the IP address of the server will change. You can see right now it's .02. If we keep refreshing here, it'll take a few refreshes, but eventually we'll be connected to the other pod that makes up that deployment. There we go. You can see it just changed. Took quite a few random requests, but now the server address and the server name have both updated. So that's the fundamentals of Kubernetes services. We use services to expose a pod or typically a group of pods, abstract away all the underlying IP address information, and typically do a load balance deployment across multiple pods that are providing the same service. I'll see you in the next lesson.